Hello YouTube, quick teardown video for you today. This is another bit of aeroplane. It is part of the anti-skid mechanism of a commercial aeroplane. I think it was a TriStar or something. It's mainly just circuit boards inside, but I thought I'd take it apart, show you what's in it. Front panel, as you can see. Sorry about the quality of the lighting, I've not quite got it worked out in here yet. So what have we got? Well, lots of wheel sensors and a few amplifiers. Get stuff out, show you the boards. Boards are very firmly clipped in. Obviously there's quite a lot of vibration on the aircraft, so they go to some fairly considerable lengths to stop things rattling apart. All the chassis is riveted together actually. First board, let's zoom in a bit. So very heavily conformally coated, as you can see. It's pretty old, it's 80s vintage. You've got these funny white ceramic chips here. They're not the weirdest ones, there's some other odd gold ones in here as well, which I'll show you later on. Lots of these round, old-fashioned op-amp style cases. Very heavy multi-way connector on the bottom. It all goes into a backplane. I'll take the bottom off and show you later. What else we got? There's lots of replication in this, obviously, because there's quite a few wheels on the bottom of an aircraft when it lands, when the landing gear comes down. Another one the same. This one doesn't want to come out. Another one the same. And I know this one is the same, it just uses these really odd gold packages, which I don't think anything for. Let's try and zoom out. The lighting's terrible, I do apologise. We need to get some professional studio lights. Yeah, these really strange gold ceramic packages. Like 2 layers of there's some metal with some gold in the middle. These are all comparators, I believe. Motherboard, lots of ceramic chips. Again, very heavily conformal coated. Chip with a little gold soldered or brazed on window at the top. These will look like more of the same as the ones we had earlier. Yeah, more of the same. So, there we go, lots of boards. A lot of the discrete semiconductors on this are all military reliability ratings. You can tell that because they have JAN before the part number. JAN 2N 2050. So let's have a look. Interestingly, all the screws in this are tri-wing. I've never seen tri-wing screws anywhere else before. Everything in this is held together with tri-wings, which are specially designed to be hard to unscrew. I'll try and fix that thing. So the way the wings go, it grips when you want to screw up and slips when you want to unscrew them. It's difficult to see how they thought anyone would be unscrewing bits of avionics from bits of equipment from a jetliner. It's not going to be carefully locked away in some service cupboard somewhere, but there we go. I suppose they can't just get in there sneaking in and tampering with any of it. That's one that doesn't want to come undone. Straight through the warranty sticker. Let's see if we can work this remaining loose. There we go. Even the back panel has a part number. Revision B, yeah, great. What different than Revision A? So, right, here we go. Lots and lots of wires. And some rather venerable transistors. And some ancient tantalum capacitors. And a big wiring room. Rather bizarrely, all the wires, instead of being colour coded, they actually have numbers printed onto the wire. Yeah, they actually have numbers just printed directly onto the wire, presumably to identify them within the wiring room. I don't know how much extra effort that took to print these numbers straight onto the wire. It's quite good quality wire. It's not silver Teflon. It's, I don't know what the installation is, but it's quite good quality wire. Interestingly, there's lots of, I'll just refocus for you. Lots of little joins and splices in it. Let's hack them out. Lots of little things like this where they just decided to just stick everything together. It's almost amateurish, but done with a very done lots of attention to detail. Okay, what else can I take off? Every single nut on this thing is a non-slip variety, so it's really hard to unscrew anything, especially with these stupid tri-wing bolts. Right, that's good. Let's detach this, see what we've got. Right, so that's fairly boring actually. It's just a multi-way switch. What's these little lights? Which are actually light bulbs, believe it or not. A little switch made up of 3 individual micro switches. That's a bit of an odd way to make a switch, but there we go, that's what they've done. There you go, 3 individual micro switches and a little trusty bit of plastic over the top. Fine, I guess they had their reasons. Nice metal clad resistor. And what are these? 2N3055 transistors. Again, see, these are the military spec versions. It even says spec at the top Jan TX. So you can look that up. Jan means is the base version of military specification, and then the letters after it refer to some kind of sub-specification, and they get progressively better. I forget what TX stands for. The highest you can get is S, being space rated. So there we go, that's quite nice. And they're on a massive stack of Kapton washers. I don't quite know why they felt the need to have a massive stack of Kapton washers instead of just one of them. 2N3055s aren't high voltage, they're about 60 volts I think. Again, tri-wing, why? Just why? Oh dear. Might have already suffered if I turn it down. These nuts are an example of what I was talking about earlier. So they're kind of hollow and they're squished. So I don't know if you can see that. The threaded part the screw goes through is kind of an oval shape. So they're kind of a plasticless equivalent of nylox, and they're a real pain to get off. The whole thing's full of them. So here we go. They obviously weren't too concerned about thermal coupling because there's no heatsink compound on here at all. It's just a stack of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 Kapton washers. What on earth was the point of that? Oh well, I guess I have some spare Kapton washers now. Of course, that's very boring actually. Another PCB under here. Try and take that out for you. Fairly boring actually. Just small transistors. Job. lots of wires that will come out. There we go. So this is the connector. As you can see, it's pretty substantial. Quite a nice touch is this locating strip down the middle, which for once is held in by normal screws. So if you take this strip out, the holes have little inserts which you can turn around. So it's basically a programmable plug, because you can define the exact plug that's going to fit into it. Obviously we'll replace that. So there's no danger if you have a whole load of identical units of plugging the wrong unit into whatever slot you have, because they each have this unique keying mechanism. That's quite a nice touch. It saves having to make a whole load of specific plugs for each model.